and you'll notice that there's a big red dot up in the corner there. That means everything is going smoothly. If that red dot is not there, then you should ditch it. You should tell me. Okay. So today I want to just really introduce Python to you. And the basics, basically working with numbers and some of the simplest things you can do with Python, which will already be enough to do actually a fair bit of things. Some of you have previous programming experience, maybe in Python, maybe in other languages. Try not to get too bored, and even if you are, if you think you're bored at the beginning, because we really have to start from the beginning here, there's a good chance that even in this class you'll see some things that you did not know, and that may surprise you. And I'm going to try and do that with every class, since there are people here who have zero experience and some people who have more experience. Every class will have pretty much everything you need, plus some stuff that even people with experience may be a little bit surprised to have seen. All right. And then lastly, for all the information about grading scheme, accommodations that you might need, and so on, look at the course webpage. When I work here, I will be working at the command line on my computer. I encourage you to do the same. Don't do something, I would prefer if you didn't do something like get a big, fancy programming environment. Even something that's not so big and fancy, something that's simple, like idle. Go look at the textbook. The first thing in the textbook is how to set up Python on your computer so you can do what I'm doing here. And that works for any of the major operating systems, Mac OS, Linux, or that's a lot. Mac OS, Linux, or Windows. Okay, so let's just jump right in, and we'll fire up the Python interpreter. So what is this Python interpreter? Well, it's the thing. I mean, we're programming in this language called Python. What is it? Well, it's a programming language. And how does it work? Well, Python programs get read by the Python interpreter. It interprets them, and then it actually executes them. Now, the nice thing about this is that means there's a whole sort of interactive environment in which we can test things out. And this is actually a big advantage of interpreted languages like this. There's this interactive mode in which we can just, if we're not sure what something does in Python or how to do something, we can fire up this interpreter and enter some piece of code and see what it does. So for example, here's a piece of Python code, 2 plus 4. Press enter, and it tells me what 2 plus 4 evaluates to, 6. Okay. Questions so far? Okay. So I'd like to highlight two things here. The difference between, this is the command line. In Windows, this might be called PowerShell, or it could even be called the command prompt if you want to use something really old. Under Mac OS, it's a shell. It's a place where you enter commands that deal with the operating systems and your files. That's what this is. I can, for example, look at the files in my directory and so on. And then there's the interpreter, which I enter just by typing Python. Now I'm not at the command line, even though it's the same window. I'm in something that's the Python interpreter. I can put Python code in here, and it will evaluate it for me. Individual lines of Python code. All right. So I said we were going to talk about the way Python deals with numbers today and arithmetic. So, for example, 2 plus 2 is 4. 2 plus 2 minus 1 is... It's not a trick question. 3. There will be trick questions like that, but not this one. How about 3 star 2? What does that mean? So star is the programming version of multiplication, or the times operator. I'll pronounce it times typically, so 3 times 2, and that's 6. And what about 5 plus 2 times 2? What's that evaluate to? 9. So why 9 and why not 14? Yep. Yeah. So Python arithmetic operators follow the normal rules of precedence that we learned maybe in some level of schooling. And so they don't just work left to right, because if I evaluated this left to right, I would say 5 plus 2 is 7, and then multiply that by 2 and get 14. That's not what's happening. Python uses this BEDMAS rules, which if you went to high school in North America, you would recognize as addition and subtraction are the lowest level of precedence. That's why the addition, the 5 plus 2, happens later. Division and multiplication are one level higher up. That's why the multiplication actually happens before the addition. Exponentiation is at an even higher level, all by itself. And then at the top of this thing is brackets, which are used to override the things, the default behavior. So leave that there. So if I really wanted to say add 5 and 2 and multiply the result by 2, I'd have to specify that this way. Okay. Questions? Yeah? Nope, the spaces are not necessary. Python does not care about spaces between operators or whatever. Not necessary. What I suggest is that you use spaces wisely to maybe indicate, to help the reader see things. So for example, this here might be better written this way. Then someone who's reading the code kind of sees, well, the 2 times 2 is kind of glued together. Probably that's going to happen first. So that's a sort of nice way to format that, but there's also a worse way to format it, which is like that, which is misleading because then the 5 and plus 2 are glued together and the reader might be tempted to think that happens first. But no, Python does not care about the spacing. You can use it to help people read your code more easily, but that's all it can be used for. Okay. E. So BEDMAS has these BEDMAS. We've seen addition. We've seen subtraction. We've seen multiplication. What about this exponentiation? So in Python, there's even exponentiation, which is written with 2 stars. You read this as 2 to the power 4. Anybody know what this is? 16. And that's just 2 times 2 times 2 times 2. 4 2's all multiplied together. Yep. Good question. When I'm frequently asked, Python does have the chevron operator or the caret operator, the pointy thing. It is not the exponentiation operator. In fact, this is a little bit outside the scope of this lesson. It's the bitwise exclusive OR operator. So it's not going to mean much to most of you. 2 to the chevron 4 is, anybody want to guess? 6. So don't worry about it. It's an operator, but it's not exponentiation. So don't use it for that. It's not going to give you what you expect. How about 2 to the power 300? that going to work? Put your hand up if you think this will give a meaningful result. Okay. Put your hand up if you think this won't give a meaningful result. Okay. So the minority wins. This is exactly 2 to the power 300. It's a number with about 90 digits or so, and yeah, it's completely correct, computed exactly the way it's supposed to be. For some of you with programming experience, this may be a little bit shocking because in most other languages, integers, which is what this is, they have some kind of upper bound on how big they can be, and once you get beyond that upper bound, weird things start to happen. Usually you just get results that are small and don't make any sense unless you really understand what's happening behind the scenes. But in Python, that's not an issue. If you take an integer and you raise it to the power 300, that works fine. Now you can even do 3 to the 3000. That also works fine. That's the exact value of that thing. And there's sound coming from somewhere. It's not my microphone doing it. And it can't be my computer because my computer's only connected to VGA. It's not even connected to the sound from this thing. Really? Well, I mean, the main volume turns it down, so it's not the projector. On the other hand, turning off all the microphones doesn't turn it down. So I think we're going to be stuck with it. Yeah?
I know earlier when your screen went black, it would, the humming sound would leave.
Okay. But
the sound only came up when you had something to
really? Oh, really? It doesn't like to... That's a bit strange because the laptop is only sending a video signal to this thing. There's absolutely no sound signal. Sorry. I guess I will try to keep down the number of characters on my screen or the amount of whiteness on my screen until we can figure that out. Maybe I'll try an HDMI adapter next time I come to class. Okay. Back to it. All right, so we just saw exponentiation, and we saw that big integers for Python are not a problem. And I guess one of the other things that we can look at here, so addition, subtraction, multiplication, exponentiation. So let's look at division. 3 divided by 2. What's that? 1.5, as we'd expect. Okay. Something to look out for, and I'll get into this shortly, is that number 1.5 is a little bit different than the two numbers that were used to create it. 3 and 2 are integers. 1.5 is not an integer. It's what we call a floating point number. It's a little bit different, and we'll see some things about floating point numbers soon. But just know for now, division works the way you expect it to. It fits into the order of operations the way you would expect it to. All right. So now we've seen all these things. Let's try to do something mildly useful. And I'm worried that this sound system is going to scream at us, but let's try it anyway. Today is January 7th. You hear that? Okay. So let's try to do something useful. Let's do, a sort of basic thing from high school. Let's compute the area of a circle. Okay. So, how do you compute the area of a circle? Can anybody give me a formula? Pi r squared. Okay. Sounds good. What's r? The radius. Okay. So let's write a function that computes the area of a circle. Def area of a circle. So I'm introducing a lot of things here. R. So this tells Python that I am defining a function. The function's name is area of circle, and it takes exactly one argument, r, which is the radius of the circle. And what do I want this function to do? Well, I want it to return the area of a circle of radius r. And so someone told me that that's pi times r squared. That looks a little bit messy to read, so let's use that trick of separating things a little bit to make it obvious that the r squared happens before the multiplication. All right, is that going to work? Let's run it and find out. So I created this in a file that is called day1.py. That's also available on the course webpage. As soon as this computer is connected to the internet, it'll upload to my Dropbox folder, which is shared off of the course webpage. So let's run it and see what happens. So what happens is absolutely nothing. And why did absolutely nothing happen? Well, I defined a function, and then I told Python to load that function, and it did. And then it quit. It stopped. Okay. So it did exactly what it was supposed to do. The function is defined. Nobody ever used the function, so then it said, okay, I'm done. What I would like to do is use the function, and for that, I want to tell Python, okay, load that file, read what's in the file, interpret it, and then enter interactive mode, which is the mode that I've been using to show you these examples. So for that, I just give Python this -i command. Because by default, if I give it a file name, it thinks the whole program is in the file, it'll run it and then quit, which is what it did. Okay, so now it's loaded that file, but it's letting me now do something. And, well, I've defined this thing called area of circle now, so let's try and use it. So let's ask it for the area of a circle whose radius is 2. And finally, something happens. What happened? Yeah?
Your variable pi is not defined anywhere.
Good. So I want you guys, so I want you guys to pay attention here. This is a mistake, deliberate, because you will encounter these things all the time. So you'll write some code, you'll try and run it, and what you're hoping happens doesn't happen. Instead, you get some message like this. And when that happens, don't say, it didn't work, I don't know what to do. Read the message very carefully, because there's a lot that's happening there. Unfortunately, there's also a lot of sort of other cruft around it, but it's telling you many things. It's telling you that on line 7, in this function called area of circle, at this line, and it's showing you the line, return pi times r squared, an error happened. And that error is what's called a name error, which is what Python tells you. It's the errors that say, I encountered a name and I don't know what that name means. In this case, there's this name pi, pi, it's not defined. Okay. So we need to define pi, or instead of defining it, we can either define it or we can do, just put in the value of pi there instead. So let's do the simplest thing. Just write the value of pi in there. So what is the value of pi? It's about 3. Yeah, 3.14. Something like that. There's a rough approximation of pi, only very rough, but we'll use it for this example. If you want a more sophisticated approximation of pi and you have an internet connection, you can look up the first 10,000 digits of it and copy and paste those here, though I wouldn't really recommend it. So now let's try the whole thing again. All we did was we got rid of this variable, or this name pi that we were using, which was causing an error, and we were just replaced it with the number that we'd like to use instead. So now let's ask Python for that area of circle of radius 2. That looks about right. That's r squared. 2 squared is 4. So now it's 4 times 3.14159, 12.566. That looks about right. And indeed it is. Yeah. I'll tell you very quickly that Python has a library that we can import that recognizes a bunch of things, including pi, and gives you some other math functions like square roots and logarithms and things. It's there, but you have to tell it where to look for it. Okay, so the answer is Python does not recognize pi, but the Python libraries have a definition of pi in them if you ask for it. Okay. All right, good. That was a sort of an easy one. And let's try something maybe a little bigger. Let's try the area of a triangle. Anybody remember how to compute the area of a triangle? Surely someone does. 1/2 the base times height. And I love that formula. That's the one that I learned, 1/2 base times height. Why we don't say base times height divided by 2, I don't know. But that's the thing, the expression I remember is 1/2 base times height. So that suggests that, well, if we're going to want to use that formula, we'd better take 2 parameters. One can be the base, the other can be the height. And I will return the base times the height divided by 2. Look good? Yep. So let's quit and load all that up again. So let's say a triangle of height 1 and base 1 has area 1/2. 1 times 1 divided by 2 is indeed 1/2. And we can test it with other values, and actually it'll work. So any questions about what's happening here? There should be questions because a fair number of things are going on. Yep.
Why don't you put the 2 ones inside the brackets?
The 2 ones inside of brackets. Which 2 ones?
In the Dropbox, I think it's called the command with the area of the triangle.
Oh, yes. Okay, good. So there's a whole bunch of syntax things happening here. One of them is we're doing a bunch of stuff here. We just defined some functions. So for example, in Python, def is a very special word. It means we're defining something. In this case, it's almost always a function that we use it for. It's a function, and that function we're going to give it the name. It's area of circle. Then we're going to give it a list of arguments that it accepts and the names of those arguments. In this case, there's only one thing. It's an R. It's an argument called R. And then a colon that tells us, all right, that's the sort of beginning of our definition. After this colon comes the real body, the real stuff that the function does, which is not very long. It just returns 3.4159 times r squared. And r, it knows what that is now because that's actually the name of the parameter to it. And the same thing with area of triangle. Everything is done the same way, except area of triangle takes two arguments, b and h. And then it evaluates, this expression and returns whatever the value is. So that's defining functions. So let me just write that in here. This is defining two functions. And over here, what we're doing is we're not defining the function area of triangle. It's already defined. We're actually calling the function or executing it so we can figure out what it does with these two arguments, 1 and 1. So the 1 are in parentheses here because we're calling this function area of triangle that someone told us it takes these two arguments. They happen to be named b and h, and I want b equal to 1 and h equal to 1 when I call it here. I can make them 3 and 3. Then b is equal to 3, h is equal to 3, and 4.5 is the area of the triangle. Okay. So, in math, it's a fairly common syntax for calling functions, like you've seen sine and cosine. Usually the arguments to those things are in parentheses, right? So the same thing happens almost universally in programming languages. Yep.
So for the defining function, is it always just return and it's one line?
No, these are exceedingly simple functions, which we're able to compute in one line. Typically, a function will have multiple lines, and I'll actually show you an example right this second using a function that we already have. And that actually gets a little bit into how code is formatted in Python. So let's go back to this area of circle business. We tried using this variable pi, and then Python told us pi was not defined, so we just erased it and put in a number instead. But maybe that wouldn't be satisfactory. Instead, we could have done a solution like this. We could have defined pi. And then once pi is defined, then we can use it. Okay. So in Python, defining a variable is a really easy thing. You just write the variable name and you assign something to it with the equals operator. So this now says, when you're executing this function, in that first line, define a new variable called pi, and its value is 3.14159. Later, if you happen to see the variable pi, it's not going to be an error anymore. It's actually defined. And we can just test that, make sure that it does what we think. Still does exactly the same thing, but now maybe the return value is a bit more meaningful, a little bit easier to read or to understand what's happening because we used a meaningful name for that number. Maybe somebody a little bit less mathematically savvy wouldn't have recognized 3.14159 as an approximation of pi. Now they can see that. Okay. So then a little bit about the way code is written in Python. If you've programmed before in something like Java or C, you may have seen lots of curly braces that sort of tell you, they delineate blocks of code. In Python, that's not what happens. In Python, code blocks are delineated by indentation. So looking at this function here that I've just defined, area of circle. So there's the definition, the thing that tells us we're starting to define this function. It finishes with a colon, and then comes the so-called body of the function. That's these two lines here. Now, how does Python know that these two lines are the body of the function and they're the whole body of the function? Well, it knows that because they're indented exactly the same way. So the first line is indented, and the next line matches that indent. And if we had a third line, we'd make another one that matched exactly the same level of indentation. In particular, Python knows that we're done defining area of circle when it comes across this line here, which is no longer indented. Yep? In Atom?
Yeah.
So usually tab, and if you're editing a file that finishes in .py, the file extension is .py, then usually just pressing tab in Atom will get you to the right level of indentation. Yeah.
Okay, because like when it was just returned and had the number there, it worked fine. When I tried to add the second line in the body, it just stopped working.
Yeah, I'll take a look at it after.
Okay.
Yeah. So one thing that I actually encourage all of you to do in this course, that is going to be full of little questions like that, is I would like you to post your experiences on the course forum. So if you say, I was using Atom and some weird thing happened and this was the way to fix it, or I don't know how to fix it, post it on the forum. There'll be somebody else who knows how to fix it or is having the same problem, and you guys can work it out together. You can also talk to me after class. Okay. All right. So that's these methods of defining functions. Let's do a couple more things quite quickly. So I asked you what 3 divided by 2 is, and most of you correctly said 1.5, but there may have been a few dissenting voices. Is there anybody who thought 3 divided by 2 would be something else? No, you don't want to admit it anymore. Yeah? Yeah. So if you've programmed in other languages, you might think, well, sometimes when you do an integer division, you expect the result to be an integer. That's not what happened here. I took two integers, 3 and 2, I divided 3 divided by 2, and I got something that's not an integer, a float. In other programming languages, sometimes it'll force you to get an integer. And if you really wanted an integer, you could ask for it just by saying, I would like this thing as an int. And well, you asked for it, and you got the answer 1. So in integer division, 3 divided by 2 is 1. Not particularly useful, but this int thing, basically, don't think of it as having anything to do with division. What it does is it takes a float, in this case 1.5, and converts it to an integer. In this case, it treats it as a 1. Yeah?
When I do that, when I do 3 divided by 2, I get 1 without entering an integer.
Okay, so you're running Python 2 point something then, not 3 point something. This was a mistake that the Python language designers made. It lasted up until version 2 point something of the language, and finally they bit the bullet and just changed the definition of the language, breaking lots and lots of old Python code in the process, but I think it was the right thing to do still. Quick question, what do you think, what happens when I convert 1.6 to an int? It's also 1. So it doesn't do anything fancy. There's no rounding or anything. It's just pure truncation. Just erases the fractional part. Okay. Now, sometimes you would like this kind of integer division to happen, and Python has a special operator for that. It's called the div operator, and it's just 2 slashes in a row. And it does, you give it an integer divided by another integer, and what you get is an integer. In fact, it's what you get like when you were a kid and you were first learning about division, and usually they give you examples where things divided cleanly. So, you would never divide 3 by 2, but you might divide something like 6 by 2, and you get the answer 3, nice and clean. Very good. But, you might have also learned, well, if I divide 7 by 2, then I get 3, and there's a leftover. There's a remainder. Okay? And it's often very useful to separate these two things, the whole part and the remainder. So 7 divided by 2 is 3 point something. What's the something? Well, I can get the something using another operator, which is the remainder operator or the modulo operator. So 7 divided by 2 is 3, and you have 1 left over that you couldn't divide cleanly into 2. Okay. This turns out to be a really useful thing. So this integer division is often useful. And let's just think for a second where you may have seen this before. Does any of you own a microwave oven? Or your parents, maybe, own a microwave oven? Does it still have buttons with numbers on the front? Yeah. So on that microwave, if you push 9, 0, and then start, what happens? So it's interesting. It actually seems to depend on the implementation of the microwave. I've seen both things. Sometimes you press 9, 0, start, and it starts counting 90, 89, 87. Sometimes the moment you press start, it shows you 130 on the microwave, which is supposed to mean 1 minute and 30 seconds. Okay? So how does it do that? How does it show you that 130? So let's see if we can write this microwave display function that would do that for us. And we'll call that seconds to minutes and seconds. It's a function that converts a number expressed in seconds and converts it to minutes and seconds. So it needs to take that number and split it into 2 parts. It needs to figure out how many minutes there are. So if S is the number of seconds, how many whole minutes are there? Well, so let's say S is 90. How many minutes are there in 90 seconds? There's 1 whole minute. And that's because that's 90. How would I get that? Divided by 60. So 90 divided by 60 is 1.5. That's telling us that there's 1.5 minutes in 90 seconds. I'm only interested in the whole part, the 1 part. So I'll take S, this time that's expressed in seconds, and div it by 60. So take an integer division. Now, I would also like to get the other part of it. After I take away all the full minutes, I want to know how many seconds are still left. So if I had started with 90 seconds, I realized, okay, I divide that by 60. That gives me 1 full minute. And how do I get the rest of it? Yep. Yep. So it's the remainder when I divide by 60. An incredibly useful operation, this taking the remainder. So if I want to take time expressed in seconds and split it into whole minutes and seconds, this is the way to do it. Do an integer division by 60, and then ask for the remainder modulo 60. Let's test it out. Seconds, 2 minute seconds. Let's try 90. 1 minute, 30 seconds. Try 99. 1 minute, 39 seconds. 600 seconds. How many minutes? Seconds? This is one you can figure out. 10 minutes. 3,600 seconds. $60 minutes or 1 hour. Okay. So there's a really sort of good use of this integer division and modular arithmetic, and something else that you've just seen, probably for the first time ever for anybody who's not programmed in Python before, is a function that returns 2 values, just like that. If I want to make a function return 2 values, I just have to put a comma between the 2 values I want to return, and to make it look nice, I can put brackets around it, but even that's not necessary. So it returns something that's called a tuple. In this case, it's a 2-tuple consisting of 2 values, the time in minutes and then the remaining time in seconds. Yeah?
How would you instruct to show that a minute, number of minutes, all seconds?
Okay, so we will see next class, we'll start working with strings and formatting, and we'll see how you can take numbers and convert them into nice looking strings that you can print. Okay. And I think that's about all we have time for. No, we're here till 4. Good. Oh, good. I thought that was passing quickly. All right. Questions about that? Okay. So even for those of you who've programmed before, you've probably now seen something you've never seen before. Yeah?
Just so I can write down my notes, what does the modulus do again?
Modulus is the remainder after you do integer division. So, if I say 7 divided by 2, well, 7 doesn't actually, it's not divisible by 2, but 6 is. So that gives me 3, and then there's 1 left over, and that's the modulus. That's what it gives you, the leftover. So actually, when you take the pair, which is the division, the whole division, and the modulus, you don't lose anything. I mean, you still then know all the information. It's just split up. Okay? Yeah? The double forward slash is this integer division. So, because if we just did s single slash 60, we can try it. Then that first result becomes 1.5, which is not really what we wanted. We wanted to know how many minutes, not how many, whatever, fractional minutes. Okay. So this is something that shows up in Python is this integer division operator that's actually, it's really useful. Even though it kind of looks like it's incorrect, but we often do this kind of splitting things. Okay. A little bit more about this difference between integers and floats. So let's 3 minus 1. So back to the basics. What's that? 2. 3.0 minus 1.0. Yeah. Good question. So the question is, what's the difference between return and print? Return inside a function means the function will stop at that point, and the value that comes out of the function is what's returned. I mean, what's in this return statement. Print does not stop the function from executing. It just prints the value that is its argument, and the function continues to execute. In particular, print doesn't have any value associated with it. So let's, that's such a good question. Let's do a quick example. So we'll copy this function, area of circle, but instead of returning, we will say, we'll print. And this is one that trips up many people. It's in fact one of the reasons we have assignment 1 is I want this out of the way by the end of this week, the difference between print and return. So let's test it out. All right, so on the surface, they both kind of look the same. And print area of circle. Looks like they do the same thing, right? Well, here's the difference. With area of circle, I can say x is equal to this area of circle 2. And then if I look at the value of x, it's 12.56 something. If I say x is equal to print the area of the circle, so already something different has happened. In one case here, nothing got printed. Here, something got printed, which is already a distinguishing feature, but the really different thing, the thing that makes these very different, are that x now has no value. Okay. So this function here, print area of circle, doesn't return anything. In fact, a little more precisely, it returns something called none. So when we say x is assigned this value, that comes out of here, x is assigned none, nothing. So that's the difference between print and return. Print just puts it there on the screen, and that's it. Return actually returns it. It means you can use it to assign something. And now the Python interpreter, it kind of tries to make a guess when you're using it interactively like this. It tries to figure out what it should show you and what it shouldn't show you. So when I write something like x here, well, it realizes him writing x has absolutely no value, it doesn't change anything, doesn't do anything. So he must be asking me what the value of x is, and then it tries to show me, but there's nothing there to show. Where if I say something like x equals 5, it looks at this command and says, well, actually, here he's assigning 5 to x. He probably doesn't want to see 5 show up again, so it doesn't show me anything. But now it shows it to me. So that's why there's this confusion when you do things like you say area of circle 2. It runs this function. It returns this value, 12 point something. And the Python interpreter says, hey, he's not doing anything with this value. He didn't assign it to any variable. It looks like we're going to lose this value at this point if we don't do something. So I'll print it so he can see what it is. That must be what he wanted. And that's why you see it show up there. But if I assign it to x, the Python interpreter says, well, okay, he's saved the value that came out of that function. He probably doesn't want to see it. That's one of the drawbacks of this interactive interpreter, is it can confuse people, the difference between print and return, but they're very different things. Okay. Other questions? Yeah. For the print, I need the brackets. Print is a function, so we're calling that function, and like all the other ones that we've been calling, you put brackets around the arguments. So the argument, there's one argument in this case, it's that value that we're printing. The last one, no. So Python tuples can be created just by putting commas between values, and that works fine. I find it troublesome somehow because it just looks too weird to me. But those brackets are unnecessary. Okay. So I asked you what 3 minus 2 was. You correctly said 1, or maybe it was 3 minus 1 is the example I'm interested in. 3.0 minus 1.0. 2.0. 0.3 minus 0.1. What? Okay. So here's where we see a significant difference between integers and floats. Integers are just that. They're real integer numbers. You do arithmetic with them. The arithmetic is correct. It's perfect. Everything is great. Until you do division and you make it into a float, then who knows what happens. And weird things can happen, as you can see right here. Okay? So floating point numbers are just some approximation of what they're supposed to be. And internally, that's a binary representation. So there's some things like 0.3 and 0.1 that can't be quite represented exactly, because 3/10 and 1/10 can't be represented exactly in binary without some continued fractions. So that the result is these things aren't precise. There's little mistakes that happen. Like, it's very close, right? I mean, the answer should be 0.2, and it's really just almost makes it there. You know, there's 10 or 15 digits of. It has to go quite far out to not get there, but it's not exactly, the right thing. And usually that doesn't matter. For most things you're doing, that's not critical. But it means you have to be very careful when you're doing programming. And one of the things you should really avoid, well, if you can avoid them at all, don't use floats, because it does make these mistakes. It causes these little mistakes. But if you have to use them, and in particular if you have to compare them, never try to test if two floats are equal. And the reason is, well, so take 3 minus 1, and let's ask if that's equal to 2. The answer is yes. 3 minus 1 is equal to 2. Let's take 0.3 minus 0.1 and ask if that's equal to 0.2. The answer is no. Okay. And that's because there's that little mistake that happens when you take 0.3 and subtract 0.1, which means that it's not equal to 0.2 anymore. Okay. Usually, it doesn't really make much difference unless you try and do something like compare these things to see if they're exactly equal, because they're not exactly equal. So try to avoid it. A lot of you in the sciences, if you end up using Python in your careers, it will be for doing things like simulations, some kind of data analysis, number crunching. This is something that can come and bite you in the posterior if you're not aware of it. Okay, and this is lecture 1 of intro programming, and you see already there's some real pitfalls here just from doing basic arithmetic. And this is a nice language, one that tries its best to take care of you and keep these things from happening, but they still show up. Okay. All right. So a couple more things that are helpful in the first assignment. So somebody asked, well, isn't there a pi? Doesn't Python know about pi already? Yes. Python has a huge assortment of libraries associated with it. That's one of the best features of Python, is all of the stuff that people have already done in Python that you can use, including the standard libraries. And Python has a library called the math library. And you can get the stuff in the math library. There's a couple of ways of doing it. One way is to say, import math. That has a little drawback, because if you import math, then whenever you want something from the math library, you have to specify that it's from the math library, but it's there. For example, math.py is there. So there's a variable now called math.py because I imported the math library. Before I did that, it wouldn't be there. If I want to take the square root of something, then I can say math.square root 200. 14.4, that's there. There's logarithms. How many of you know about logarithms? Okay. Is that because you took like some advanced functions course in high school or something? Or you just learned them here? You know, from somewhere. Okay. What do you think log of 10 is? 1 is a potential answer. The answer is you don't really have enough information because you don't know what base the logarithm is. But here's a hint. In mathematics and computer science, when someone takes a logarithm, it's almost never base 10. Base 10 is like almost irrelevant in mathematics and computer science. In computer science, base 2 is particularly popular, and in mathematics, it's ln, the natural logarithm. Log to this, where the base is this magic number e, which is not even, you can't write down, but you can define it in terms of a limit of 1 minus 1 over n to the n as n goes to infinity. This is log base e by default. Okay. If you want to change that, it has a 2-argument version where there's the binary logarithm, the base 2 logarithm, and then what you may have been thinking of is the base 10 logarithm, in which 10 to the power of 1 is 10, therefore the log base 10 of 10 is 1. That's useful for the assignment. And here's another. We can also look at math.e. That's the base of the natural logarithm, and we can check that that's true. If we compare that to what you get without specifying the base, it's exactly the same thing. Okay. Questions there? So now is a good time to ask me anything about anything that's confusing. Everything we've done in this lecture is still up there. You can refer to it. Yeah. Yeah. So now that we know about this math library, here's the way I would write this. One way to write this, I could say import math. Let's not define pi. Let's not define pi there. Here we can just say math.py. And here we can just say math.py. That's a little bit cleaner, and we get the best approximation of pi that we can get. It's the one that's in the library, and presumably the library maintainers are doing a good job of keeping up to date with further developments in the value of pi. That's not true. The value of pi is known well way beyond what they need to update it. Okay. More questions about that? Yep.
For the previous question, how did you open the day one stat?
How did I open?
It's just the day one notepad.
Okay. So let's do it again. I'm running probably a different operating system than most people in this classroom. On this operating system, there's a text editor called gedit. It's not a great text editor. It just happens to be the default one that ships with it. So I just ran gedit, so the gedit command with the argument day1.py. Now remember, so notice what I did just before showing this. I quit the Python interpreter, back into this command prompt or command line, and so this is back in, drop down to the level of the operating system saying, hey, there's an editor on here called gedit, run it and pass it this argument, and that's what it does. Okay. Oops. And now I'm not in Python anymore. If I start doing things like this is something that people come up to me all the time after class. They type in code here. It's like the command 2 is not found because this is not Python right now. This is the command line. Okay. All right. So then I think one of the last big things we want to look at, and we've already seen a little bit of this. So we've seen brackets, exponentiation, division, multiplication, addition and subtraction. And division, well, actually we've seen the division operator and the div operator and the modulo operator as well. So there's actually a lot of things in there, all gathered up in there. So different kinds of division, and even this modulo or remainder operator was in there, brackets and so on. But there's yet another level of operators which is lower than all of these things. And we've seen one of them, and that's when I ask questions like, is 3 minus 1 equal to 2? So there's this double equals operator that it's not declaring that 3 minus 1 is equal to 2. It's asking a question. Is 3 minus 1 equal to 2? In this case, the answer is yes. But it's just one of these binary operators like all the other ones, like the subtraction operator, like the multiplication operator, like the division operator. So it has to fit into this bedmass thing somewhere. Now, where does it fit? Well, we can figure it out. So that also does the thing that we would expect. So that suggests to me that when it's deciding what it should do first, the subtraction or the equality test, it's not just doing this left to right. Because in the first case, yes, if it did it left to right, it would say 3 minus 1, that's 2. Is that equal to 2? Yes, it is. In the second case, if it was doing it left to right, it would say, is 2 equal to 3? No, it's not. So that's false. And then subtract 1. That doesn't even make sense, right? So take false and subtract 1. That doesn't sound plausible. So it must be doing what we expect, which is subtraction is at a higher level of precedence than even addition and than equality tests. Okay, so at the end of this thing, there's even another one. The lowest level of operators are these equality or comparison operators, and there's a whole bunch of these comparison operators. That include things like, is 2 less than 3? Someone tell me the answer. Okay. Is 2 less than or equal to 3? Okay, good. Most of you said yes. It happens sometimes that people say no to that question. 2 is less than or equal to 3. It's not equal, but it's less than. Okay. Reverse these. Is 2 bigger than or equal to 3? That's false. Is 2 bigger than 3? That's also false. Okay. So there's those comparison operators that let you tell whether one thing is bigger than or equal to another. We've also seen the equality operator that tells you whether two things are exactly equal. And there's the inverse of the equality operator, which asks you, are two things not equal? Is 2 not equal to 3? 2 is not equal to 3. That's true. So when you're not sure what exactly this means, just try saying it out loud. 2 is not equal to 3. That makes sense. Good. If you say 2 equals 3, that doesn't make sense, so it must be false. Okay. Now, again, I mentioned these floating point numbers you have to look out for. Floating point numbers work usually great with these greater than, less than comparisons. Just don't use equality tests on floating point numbers because you can get surprising results where things that mathematically should be equal turn out not to be because of these little errors. All right, so that's all I want to teach you for today, but I'm happy to answer questions if you want to come up or ask them now.